All right, now the first problem, if this was what you want to do is write the relevant formulas so you can see how one variable is affected by something else. Yes.
Are you making these podcasts?
Yes.
Okay.
So what we have here is a simple pendulum. So our formula for a pendulum is T equals 2 pi square root of L over G. But the question here is, it says, if the length of the pendulum is halved and the mass is tripled, what will happen to its frequency? Well, the formula for frequency, now frequency and angular frequency are not the same thing. Angular frequency is the omega, and frequency is like that italics F. And that is 1 over the period. So what I want to look at to figure this out is I want the formula for frequency in terms of the variables that may or may not affect it. And so since frequency is 1 over the period, then I'm going to just flip this over, and that will be my equation for frequency. Then I can look at that and see how one variable might affect something else. So this is going to have, so frequency will be 1 over 2 pi, because this one was 2 pi. And then if I flip this over, it's going to be the square root of G over L. So I'm looking at that, and maybe I should, let me put in the variable that they're using for the length of the pendulum. So that's my equation. Now it says the length of the pendulum is halved and the mass is tripled. Well, the mass being tripled is not going to affect the frequency. But the length, if I have the length, if the length of the pendulum is halved, so that becomes 1/2 L, then just look and see how would that affect it. Now, if it was, let's say, if this was 4 times bigger, then the square root of 4 is 2, and I would double the frequency. If the length was 4 times bigger, then it would be half of whatever it was, because 4 inside a square root would be 2 outside a square root, but it would be under a fraction, so it would be half. Well, if this becomes half, then notice that the smaller the length of the pendulum, the bigger the frequency. So the frequency is going to go up. So it's going to go up by, if I look here, and if I were to put in 1/2 L instead of L, the only difference would be, it would be just like having a 2 in the numerator instead of a 1/2 in the denominator. So if it's a 1/2 in the denominator, then it's the same, that would be like a complex fraction, because it would be a fraction over a fraction. It would be a fraction inside of a fraction. So if 1/2 L would be the same thing as 2 up there. So the difference between this right here and if I put in 1/2 is square root of 2. So the frequency is going to be increased or larger by a factor of, because the 2 would be up there and it's under a square root, it would be increased by a factor of the square root of 2. Square root of 2 is a number bigger than 1. If you multiply anything by a number bigger than 1, then that means it's going to make the number bigger. If you multiply by a number less than 1, it's going to make it smaller. If you divide by a number bigger than 1, it will make it smaller. And if you divide by a number less than 1, it will make it bigger. So in this problem, like I said, all I'm doing is, that's my formula. So I know that there's only 2 things that can affect the frequency: the gravity and the length of the pendulum. So if I replace L with 1/2 L, that's the same thing as that being 2G over L. And the difference between this and 2G over L under a square root is the factor square root of 2. So any questions on that one? That's the only one actually on the other version of the test that I did.